Welcome, my name is Jason Berland with Hamlet. Today we're going to talk about the installation and safety features regarding a dual ferrule mechanical grip compression tube fitting. Traditionally, the sealing technique involved with a dual ferrule mechanical grip compression tube fitting is dissimilar to traditional threaded sealing methods, and some issues arrive when installing it as you would a threaded fitting. So we're going to talk a little bit about that. We're going to talk about the components and it's a little bit of tube selection guidelines as well. Getting into it, I know that we call this a dual ferrule mechanical grip compression tube fitting. I know it's a mouthful, but if we take a look at it piece by piece, you'll understand why we call it that. First of all, of course, the dual ferrule function. If we take our tube fitting apart here, we see that we have two separate ferrules. The components that we have here are fourfold. We've got our nut, our back ferrule, our front ferrule, and of course our tube fitting body. The important thing to realize here is that with the two ferrule system, each ferrule has its own function, and that is the back ferrule is what grips our tubing and holds everything in place, and the front ferrule is where our leak tight fluid seal is obtained. The orientation and alignment of these ferrules is key. They have to be in this order in order for the tube fitting to function properly, and that's with the front ferrule, the tapered end, diving into the body cone of our fitting body here, and then the back ferrule, again the tapered end, diving into the back of the front ferrule, and of course the nut goes on top to encapsulate the entire assembly. When we call it a mechanical grip tube fitting, that means that when we assemble this, we pull it up based on geometry. There is no such thing as tightness involved when dealing with a tube fitting. We say that because in order for this to seat properly on our tubing, we need to move that back ferrule forward 0.0625 inches. And the way that we do that is by turning this nut 1 1/4 turns. The reason why we say there's no tightness involved is that you will feel a different amount of tightness depending upon what size tubing you're using, what material of tubing you're using, the wall thickness as well. And so all of these variables come into play, and we need to make sure that we're always moving that back ferrule forward that specified distance. And that's why we always say we pull it up based on geometry. That creates our mechanical grip. That creates the sealing function as well. We also call it a compression fitting, so that's the third portion here, dual ferrule mechanical grip compression tube fitting. The reason why we add that in there is because this is not a bite type fitting. This is a fitting that's made up by literally compressing the tubing. If you might think of a tube of toothpaste, when you compress one area and squeeze one area, another area will expand. That's where we get our swaging function when installing a tube fitting of this nature. So the ferrules will actually be permanently installed onto the compressed piece of tubing upon installation. One thing that I do want to talk about before we get into the proper assembly is tubing selection. Now, one thing to remember when you are selecting your tubing is that we do have a sealing surface on our fitting, but we also have a sealing surface on our tubing. The entire length of the outside of a piece of tubing is actually where we're going to be creating a seal. So we need to make sure that our tubing is free from scratches, indentations, anything that may create a potential leak path when installing our fitting upon it. So the other thing to be cognizant of is that you want to make sure that you're using similar and compatible materials when selecting your tubing and your tube fittings. You don't want to mix dissimilar metals like a brass tube fitting with stainless steel tubing for a number of different reasons. But As long as you're selecting similar metals that are compatible, you won't have that issue. The wall thickness of a piece of tubing designates what the pressure rating of that tubing and that system is. We are often asked what the pressure rating of a tube fitting is, and that's a little bit tricky to answer in the effect that when you overpressurize a system, the tubing will actually burst prior to the fitting starting to leak. So with that in mind, and if we know that the weak link in this system is our tubing, we can actually say that the tube fitting is rated to the working pressure of whatever the tubing is that it's been properly installed upon. That leads us to our actual proper installation. We talked again about how we need to turn this nut 1 1/4 turns. For the purposes of this video, we are going to discuss the installation of tube fitting sizes 1/4 inch and above, or 6 millimeter in metric. That does not include 1/16, 1/8, or 3/16, or in the metric variation 2, 3, and 4 millimeter. In these circumstances, it's only 3/4 of a turn in order to achieve the pull-up. But for the sake of this training, we're going to speak about 1/4 inch and above. Specifically, we're going to be working with 3/8 tube fitting and tubing here today. So we're going to stick to that 1 1/4 turn. We talked a little bit about how we need to move that back ferrule forward in order to create our seal. What happens in a quality tube fitting is that at every 1/4 of a turn, the same functions happen in the same order every time you pull up a tube fitting. And we're going to go through that here. The important thing to remember when installing a dual ferrule compression mechanical grip tube fitting is that we need to have a wrench to back up the body, or in this case we're using a vise. We don't want to turn the body in order to make up this fitting. We are going to be turning our nut. We want to make sure that our tubing is fully bottomed out into the shoulder of that fitting body and that it's finger tight. At this point, I'm going to make a mark on our tube fitting body and our nut in order to indicate at which point we are beginning to install. From here, we'll take our wrench and turn it 1 1/4 turns, but I'm going to stop at 1/4 of a turn. At this point, again, we talked about the same functions happening at every step along the way, every 1/4 turn. At this point, we've brought that back ferrule forward, which pushed the front ferrule up against the body cone and has wedged those into place. At a 1/2 a turn, we have started to bring the back ferrule underneath the front ferrule, which lifts it into its sealing position. At 3/4 of a turn, we're going to get our back ferrule is actually going to begin compressing on our tubing at this point. So what you'll see, and actually if you notice the cart started to move a little bit here, at this point there's going to be an increase in torque required to continue around that 1 1/4 turns required to pull up this tube fitting. Because this is where a lot of the work is beginning to take place. We have now brought it around 1 full turn. At this point, further compression of the tubing is taking place. The front ferrule is even more so being brought into the sealing position. And lastly, that last little 1/4 of a turn required to make it go around 1 full turn and 1/4 seats everything properly. You have your tube grip from the back ferrule that provides blowout resistance, and then you also have a fully seated front ferrule providing our reliable leak tight seal. At this point, a quality tube fitting will be gaugeable. And what that means is that we can measure the gap between the fitting body and the nut and measure to see if that nut has been pulled up 1¼ turns. We can offer what we call a no-go gauge. This particular one has a couple of different sizes on it, 1/4, 3/8, and 1/2. Since we are using a 3/8 tube fitting, we'll use the appropriately sized gauge. And what we want to see and make sure is that that gauge does not enter the gap. That indicates that this has been pulled up 1¼ turns and that no additional tightening is required. It's important to note, however, that this gauge is only accurate and should only be used upon initial installation. Which brings me to my next point, is that these tube fittings can be taken apart and put back together a number of different times. You can disassemble it and put it back together knowing that you still will obtain that reliable leak-tight seal a number of different times. The way that we do this, notice I'm going to make a new mark on here, and this is going to indicate that at this point where these marks are in line, it's been pulled up sufficiently, and that's where everything is set in place. We can go ahead and take this apart. And take a look at the completed and fully made up tube fitting. At this point, the ferrules have been permanently attached to the tubing and cannot be reused unless you are using it within the same system here. But you cannot take the ferrules off and use them in a different fitting. But the nut, obviously, if it's not stuck on the tubing here, if it's not encapsulated by either another fitting, the nut and the body are both reusable in other systems, if that is what you choose to do. But I don't know if you can see it very well, but one of the things that we do want to point out is that the tubing in front of the front ferrule has actually begun to expand slightly. The tubing has been compressed here, and you can see it expands ahead of the front ferrule. Now, if I've done whatever I needed to do with this after I'd taken it apart, I can put it back together. The directions as far as reassembly is concerned is we're going to go back to finger tight, and what we want to do is bring it to the point where it was pulled up to previously and then tighten just slightly more. So I'm going to bring it to the point where my marks that I made the second time are in line, and then snug it up just a little bit more. The reason why we go just a little bit more is because if you think of that front ferrule, our sealing surface, as a metal, of course it is a metal, but all metals have a memory. They have what's called spring back, and when you release the tension on that nut, that front ferrule, our sealing surface, starts to relax a little bit. So we need to then reseat that, and by doing so we have to move that nut just a little bit further than the position that it was at before. And you can see here where my marks were in line, it's not a lot required in order to reseat that, but just enough to where they are offset. Now every time I take this apart I need to go just a step further, so I would be making a new mark each and every time. But this allows you to get multiple remakes out of a single tube fitting. If you over tighten it, let's say you put it back together and then turn it another half a turn to a turn, it may seal once or twice more, but you're limiting your remake capabilities by over tightening. The key things that I would like you to remember are that there's no such thing as tightness. We always pull up a tube fitting based on geometry. The magic number here is 1¼ turns. I'd like to thank you for your time. I hope that this video was beneficial and informative.